So now let us talk about the different types of polysaccharides. Polysaccharides. The polysaccharides primarily are of three types. The first are the structural polysaccharides. Structural polysaccharides. Saccharides. And these structural polysaccharides famously include two important carbohydrates. They are chitin, and the other is cellulose. So chitin essentially is present in animal systems. They serve as exoskeletons in animals, as well as in plants. You can call in some mushrooms. And cellulose, they are from the structural polysaccharide of plants and one animal, that is your ascidia. They have got cellulose instead of chitin. So this is the difference among them. And so let us see the structure of chitin. So you first draw this particular glucose unit. This is a common feature in all the structures. You first draw this unit. Next, H, and the oxygen is here. Since it's a polysaccharide, one side, whatever it is, n number of times it is repeated. So, and then now you draw the other components of it. There is an H, but instead of an OH over here, you have an NH, CCH3, CO group over here. And the other part is like glucose, OH, H. Then you have an H over here, CH2OH. The structure goes like this. There is a beta structure coming out from here. It goes on like this. Then you have another H. So this is essentially the bond present over here. The same structure is repeated over here. You have H, you have NH, C double bond O, CH3. You have it over here. You have OH, H, and this H goes on here, and you draw the bracket over here. This is the basic structure of chitin. Similarly, if you go towards the basic structure of cellulose, you have to draw these. Let's draw the basic structure of cellulose. You have to draw this structure first. The pyranose structure, 2 pyranose structure. H. This repeats n number of times. There is an H over here, and you have an OH over here. The OH comes over here. H is coming over here. H over CH2OH. The usual structure of glucose, it's, as you know, there is a beta linkage like cellobiose. You have an H coming out over here. then an H over here, OH over here, OH, H, the usual structure of glucose goes on, and CH to OH, and the structure goes n times. This is the basic cellulose structure. Now let us go to storage polysaccharides. Storage polysaccharides. Most important among them are starch and glycogen. Essentially they store your reserve extra glucose over here. Starch is basically in plants, glycogen is in animals. You can find glycogen in mushrooms also. So let us look at the structure first. A main chain. You have the main chain over here. It starts like this. It goes on. You draw the glucose units. Draw 4 glucose units. Four glucose units coming up over here, and they are all alpha glycosidic bonds. You join them. They are alpha glycosidic bonds. You have H, OH. So now you have OH over here. You are just drawing the structure completely. These are all alpha 1 to 4 glycosidic linkage. Alpha 1 to 4 glycosidic linkage. So you are just completing the structure of these glucose. OH, H, H, OH, H. Here let us for the time being not draw anything. In this you draw CH to OH, OH, H, H, OH. So this main chain goes on. This is the main chain which goes on, and you have an alpha 1,4 linkage. At the same time, you have alpha 1 to 6 linkage. This is CH2. Instead of OH, you have another glycosidic bond which is formed over here, and you draw the glucose link. This is a branch point over here. This is a branch point. Alpha 1 to 6 glycosidic bond. This is a branch point. And again over here, this is a alpha 1 to 4 glycosidic linkage. You draw the bonds and it goes on like this, the main chain. H, OH, OH, H, H, CH2OH. You have the H over here. You have H, OH, OH, H, 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 CH2OH. So this is a structure of a famous starch known as amylopectin. This is the structure of starch. So important to note among them are the two bonds. One is the alpha 1,4 glycosidic linkage, which you are seeing over here, and the branch point alpha 1 to 6, because this is 1 and this is the 6th carbon, 1 to 6 linkage. So this is the structure of amylopectin or starch. So let us go to the next part, which is that of glycogen. The structure of glycogen it is similar to that of starch, but what you find here is you have more number of branch points. Thus, if you see, this is a long stretch of starch, like a starch molecule goes, you find a branch point coming over here, there, that branches up like this. Then you may find more branch points coming like this. You may find branch points coming like this. You may find branch points coming like this. So lot of these branch points together, branch points coming like this, then branch points coming like this. So you formed a structure of glycogen. The next group of polysaccharides, apart from your structural and storage, these storage polysaccharides are the group known as GAGs or glycosaminoglycans. They are known as glycosaminoglycans. Basically, they are gel-like matrix substance, or you can call ground substance. Soft, like you find in your in the cartilages, in jelly-like substance in eyes. So these are all glycosaminoglycans. Famous among them are, important among the ground substances are hyaluronic acid, which has this hyaluronic acid, lubricates joints. Vitreous humor of the eyes. So let us have a look at this. Let's draw this structure again once more. First draw the two glucose structures. The H starts from here, and remember it goes here, there is the O, and from here the structure is like this, and then you have the H over here, you have NH COCH3, the group comes over here, again the H starts from here, it goes down again, so we are closing this. You have a H over here, OH below, H CH2OH. Similarly, H OH OH H, it goes on to the next one. And interestingly, in this one it is COO minus, and you have an H. This is the structure of hyaluronic acid, of glycosamine. Like this, you have chondroitin 4-sulfate, chondroitin 6-sulfate, heparin. All these structures you can find in any standard textbook like Voigt and Voigt or Srinivasan, or any standard textbooks you can check, Satyanarayan. The next part which we will go on now are glycoproteins. Glyco means carbohydrates, and of course proteins are proteins. First important among them are proteoglycans. They resemble the structure of a bottle brush. So they modulate the effect of growth factors like fibroblast growth factors. Gives structure, they form the part of chondroitin sulfate and keratin sulfate. They are covalently linked. So you have the structure like this. All these are units linked, carbohydrate units linked. This is the link protein. And now to this you are added. These are the carbohydrate groups. See that these are the glycans, or the carbohydrate part. This is of course the protein chain, CHIN. This is the structure of proteoglycans, and the last part which I come across are the peptidoglycans. Famous are the NAG-NAM units. So the rigid bacterial cell wall consists of alternating beta 1 to 4 linked NAG-NAM that are cross-linked to cross-linked by short polypeptides to form helical peptidoglycans. So let us have a look at the structure, how it goes. N-acetyl glucosamine NAG, N-acetyl muramic acid is NAM. I am drawing the structure. You have these glucose units as usual. You have to draw these two glucose units. You link them with then you have an H, CH2OH, H, CH2OH, you have an H, NHCOCH3, it goes to O, and you have an OH over here, H, and to this is linked O, CH, CH3CO. This is a lactic acid residue. To which you have amino acids added. You can call this N-glycosidic linkage. Here you find a O-glycosidic linkage. To which you have say L-alanine added. I have not drawn the structure. N-glycosidic linkage. To which isoglutamate, L-lysine and D-alanine. So I would this ends this particular chapter. I would request you to go through these lectures and the previous lecture 1, and then if you have doubts, please do contact me.